Well, hello everyone. This is KP the Math G here, and we're looking at the 2013 rather, free response question number 2. It says on the interval where t is between 0 and 5, including 0 and 5, a particle is moving at a velocity. This is the velocity equation. And the position s it is known that s at 0 equals 10. Okay. It says find all values t on the interval. I should have said what the interval is. T is between 2 and 4, such that the speed is equal to 2. All right, that's the interval right there under consideration. All right, now what we got to understand is that we're talking about the speed. Okay, what speed? Yeah. If you said that speed is equal to the absolute value of the velocity, you're right. Now remember, velocity could be positive or negative, depending. It has both magnitude and direction. So if I go forward 10 meters per second or go backwards 10 meters per second, I can go forward 10 meters per second and backwards a negative 10 meters per, or actually it's still 10 meters per second. But if I can go left and right, then or whatever, the signs are different anyway. Okay. The speed is always positive, so I know that this must be positive. So what I did, now this is my idea of what I did to understand this. I knew that then this speed is equal to 2. Alright, well, alright, the absolute value of v at t is equal to 2. Yeah, I think you get a point if you can recognize that. Now what I did on my calculator, and let me get it, excuse me just for a minute. I've been charging up my phone and my excuse me, I'm sorry, I didn't mean to leave that out here. Okay, I have a really nice calculator on my phone here, and I plotted the line. Okay, so let me show you exactly what I did. Now mine's got a y sub 0. So on my y equals, I got y sub 0, and I put in this whole function. Well, actually, I want to say I put 2 in here, and y sub 1, I put in the absolute value. And you gotta go into I think what you do is you go into math, and it does say you got to scroll over to number, and then you get into absolute value, and then it'll give you the absolute value symbol, and then you just put this in that absolute value symbol here. For shortness of time, I'm just going to say, well, you put in this v at t right here. Okay, and that's all of this right here. Put it all in as is, and then graph it. Now also on the window, I had my window set at x-min was like -1, x-max was say up to about 5 or 6. You don't have to go all the way up to 10. And then y min was say -1 and y max was up to 10, and I did that. And when I did the graph, y equals, and I drew the graph, this is what I got right here. Alright, and actually, I don't know if you can see that. I'm going to look through the lens and see if you can see that at all. Oh boy, I don't know if you can see that at all. But I do see that there is a kind of a V shape. You know, the line y equals 2 goes straight across, alright, at 2, and then this one kind of does that, and I can hit intersect, and I widen this out enough where I can see it. Okay, and I get two answers here, and I get, alright, the x values are t is equal to, alright, well, the absolute value of this is equal to 2, so in this case, t, let's put it over here, t equals about 3.12, okay, 3.128, okay, go out to 3 decimals, remember to do that, and then the other t value is 3.473. You have to be very careful. This is in this interval between 2 and 4. There is another one, I want to say, I'm not sure yet, but maybe I'm thinking about a different problem. Yeah, there is another one that is on here, but you only need to be concerned, it's somewhere between 0.75 and 1. You don't need to be concerned about that one. It's actually 0.9437, okay? You need not to worry about that one. You're only looking at the numbers between the t values between 2 and 4, and that's the only two places where it crosses at y equals 2, or yeah, okay. Okay, so those two right there, and that's how you do it. You got to remember, though, in the whole thing, that speed is equal to the absolute value of the velocity. So you already got your velocity equation. All you need to do is put that 1 into this whole thing here with the absolute value bars, or it may say ABS for absolute value in parentheses. Put that in there, okay, and then, or if it has your absolute value bars, just put it in between the bars like that, and then when you hit graph, then you can hit, I think what I have is intersect. Okay, I can intersect and immediately it'll cross right there, and you want to try to keep it zoomed in between 2 and 4, and that's all you need to look at right there. Okay, so that's a part right there. Alright, that's it. Okay, again, the absolute value is equal to 2. Alright, that's what I got on that one. I didn't write down the rest of these, so let me see if I can figure out what these are. Alright, so what is B part? I'm going to try to, alright, it says we want to look for the position integral. We want an expression. B part, we need an expression. Alright, we want an expression involving an integral, involving an integral. know I'm going to need an interval, and that gives the position. All right, that gives the position. Gives the position. All right, that's your position equation. When you take the antiderivative or the definite interval, all right, that gives the position s at t. All right, so I want to integrate v at t. Now I do not need absolute value bars, simply because I'm not dealing with speed now. I'm dealing with velocity. So what you can do is you can go back up. I want to say you can take off the absolute value bars, and you can call this up if you want to right there. One thing that is important, we need to understand that s at 0 is their position. That's always what we call an initial condition. S at 0 is equal to 10, so we need 10 right here. 10 plus. Alright. And we are looking at the interval from time t equals 0 to any time t. And I want to say we have to change this right here. So probably x. Any other letter would do. V at a, dA, whatever you want to do there. Okay, that is the position equation. You get a point for that right there. I believe you get 1 point for that. Then they say find the position when find the position. All right. The position when t equals 5. Alright, so in other words, we're just plugging 5 in here. Right here. That's what we're doing. Now remember, you can plug this in, put that into your calculator. Alright. If I were to go to y equals, I can simply remove, I can come down here, let's see if I can get it down here, and I can remove the absolute value bars. I think hitting delete one time removes it, and that's what you can do there. I deleted mine. I don't know if you have to put yours back in or not without the absolute value bars, but now I've got mine in V1. Okay, so mine is y sub 1 is what I have here, which is the same thing as v at t. Mine is y sub 1. Okay, so I put that in there and I call up y sub 1 right here. Okay, like that. I don't know if the one's the same size. It may be lower. Okay, like that. But anyway, y sub 1. I don't know if you need that in parentheses or not, but anyway, I don't think you do. Okay, you can do that, and then you will get your answer. If you plug that in, you will get an answer of -9. Alright, so this equals -9, or about equal to, because decimals move on and on and on. They continue. 0.207, something of that nature right there. Alright, so you might want to have these separated where you have the t first and then have the x, okay, like that. And that's what I did. I just put all of this in there without the absolute value bars. Okay, if you got to take time to do that, then do that. But you got to remember, you have a position, initial position. The particle is at 10 when t is equal to 0. Okay, and then add that to this. Do not leave this 10 plus out of there. Okay. All right. Okay. That is where it is. So evidently, from all intents and purposes, after t equals, or at the time t equals 5, this has moved to the left, hasn't it? Because it was already at 10, and it's moved almost to negative 10. Okay, almost 20 places over. Okay, anyway, be that as it may, it doesn't matter about that. You just need to know how to do that. Okay. Alright, that's the initial condition. Means you've got to take the antiderivative, or the definite integral, of this v at t. Alright. Alright, that was v at t. Alright. And I put that into y sub 1, and I was just able to call that up right there. And the way you do that, you got to remember, you can do that. All right. You can, if you're just on your regular screen, you just have to get into y, maybe your bar or y bar. I can automatically do that, and I have all of these right here to call up. I don't know if you can see those. Y0, Y1, so on and so forth, like that on mine. So I wanted Y1, and I just punched in Y1, okay? And that's what I did there. Alright, that's part B. I hope you understand what you're doing here. You need to take that definite integral of the velocity if you want the position equation. You have to remember to do that, okay? Alright, let's go on to C part. I think we're going to have time to do all of these. I think so. Well, let's see what C part is. Alright, I done forgot. Okay, find all the times on this interval from, okay, find all times t. So C part is find all times t, all times t, where I want to say the velocity changes direction. And I don't, I'm glad I'm not in a spelling bee today. Changes direction. Where, well, not the velocity, really, it's not the velocity, it's the particle itself. Now, okay, now that's better. The particle is changing direction. It's going in a straight line. Now remember, if the velocity is positive, it's moving to the right. If it stops, we want to find out when the velocity is 0. So it's going to stop and turn around, maybe stop and turn around, maybe stop and turn around. But each time it stops, the velocity is 0. So what we have to remember is that v at t is equal to 0. And you might even get a point if you show the graders, those who are going to be grading your papers, and they get paid pretty good to do that, to do you a good job. You might get a little credit if you put down, well, v at t is equal to 0. Now, what I found those values, okay, and let me see here. And actually what you want to do is you want to see where v, you want to see all the places where this v crosses the t-axis. Alright, right here and right here. So if this is v at t, right here, we want to find out where this crosses. So we know that it's going to the right. Let's say this is, I don't know, we're going to say 2, and then 4, and so on like this. So from 0 to 2, this is moving to the right. So we're going to put RT for right. When is it moving to the left? Yeah, it's, and then let's say here's 5 here. Okay. Alright. We got some more graph coming up here. Okay. It's moving to the left between 2 and 4. So left here. How do I know that? Well, it's below the t-axis. Above the t-axis, it's moving to the right. Here's velocity equals 0. Alright, v at t is equal to 0. V at t is equal to 0. It stops. So here it is. It's going right, then left, and then to the right again, isn't it? Alright. At between 4 and 5. And that's not the answer, but I'm just saying this is just an idea. Okay, you need to be aware of that. All you really would like to do then is I want to graph v at t then. I want to see what that looks like. And I want to see where it crosses every place where it crosses the t-axis. That's what I want to do. Okay? And then if once I get that, then I can start finding the points here. Okay? Well, let's take a look here. Alright. V at t is equal to 0. Let's see what I've got on my calculator. Alright, I do have that. And let's see, I just want to graph that v at minus y sub 1. So I'm going to graph that. And I have it right here. And I want, in this particular case, some might have zeros on it. You know, you might say the word 0. Mine has root. And when I do that, I get those answers right there. And let's see, I don't think I have anything else. It is a parabola that does this. Okay, it's going this way. All right. And it is crossing in 2 points. I don't know if you can see the points or not, but you can see the idea of the parabola here. It is crossing, and where it crosses that t-axis, that's what I want. Alright, so that's what I want right there. Alright, so okay, so in other words, v at t equals 0 when t equals, I've got two numbers, 0.536, 0.536, and also t equals, it goes out to 3.31. 3.31, I need to go a little further out, 776. Now remember, you can go out more than 3 anytime, but you have to at least go 3. Alright, you can't stop at 3.3 or 3.31, you got to keep going right here. Very least put 3.318 or 3.317, either one is okay. Alright, that's what you got to understand about C. All the times where the particle changes direction. Alright, and you might want to explain that. If you look, the particle is moving, and they may ask where, what intervals is the particle moving. Well, let's put down left, and let's put down right. Okay. I'm probably running out of time, so if I do, if this thing stops all of a sudden, just forgive me, and I'll finish it up on the next video. Alright, so between, on the interval, t is between 0 and this, let's call this t sub 1, and call this, t sub 2. Alright, so between those, okay, it's going left there, and it's going right between t sub 1, and t is between t sub 1 and t sub 2, which we'll call this is between these two numbers. It's way up above the t-axis here. Alright, so in other words, if this is the graph, then it's doing something like this, and this number is t sub 1, and this number is t sub 2. So it's going, see, from 0 to t sub 1. Exactly, it should be a t sub 1 here. T sub 1. And then from t sub 1 to t sub 2, it's moving right. It stops at t sub 1, signs change, and then it is moving left again from t sub 2 to whatever the interval is. So it's moving left again from t is between t sub 2 and I want to say the interval ends at 5. Yeah, it ends at 5. Alright, and actually we are looking at the interval t between, I want to say it's included there. Alright, like that. Now, okay, they say it changes direction from negative to positive on this interval. It's positive on this, and it changes direction, from positive to negative on this interval here. You just need to mainly have these two right here, okay? If you have this, that may give you, I want to say they give you a couple points for that, okay? And you got to have the justification there. All right, I don't know if I'll have time for the part D. This is a long video, I know, and I did take a little time to explain. Let's see what part D says first before we start diving into it. I may or may not have time to do part D. Let's see what it says though. Alright, let's see. I think I've got a little more time left. Let's see. Is the speed of the particle increasing or decreasing at time t equals 4? Okay. You know what I'd like to do there is reserve that one for another time. Now what you need to understand is the speed increasing or decreasing? Alright, so I'm just going to, without doing any work here, is the speed increasing or decreasing? Alright, and what you need to do is you really need to check out, we already know what V at t is. We need to look at also A at t, okay, and that means we have to take the derivative, which is equal to the derivative of V at t. So we got to take that derivative there, okay, and we have to examine it at t equals 4. So at t equals 4. So what we're doing is we're looking at V at 4, we're looking at A at 4, and so which is B prime at 4. Okay, so I'm going to just be brief about this and just kind of give you the answers. Okay, so V at 4 is negative 11.4757. 4757. That's good enough there. Okay, 58. And A at 4 is negative 22.29. 5714. Notice that. So then V at 4 is less than 0, negative. And A at 4 is also negative, therefore the speed is increasing. The speed is increasing at t equals 4. Now remember, because these two, they're both negative, they have to both be negative. They have to either both be negative or positive. If the signs change at all, Either the velocity is negative and the acceleration is positive, or the velocity is positive and the acceleration is negative. That's decreasing. But since both of these are increasing, are both the same sign, the speed is increasing at t equals 4. And that's really all I have on that one. I wish I could have spent a little more time showing you how to find those values there, but I at least want to get that in because I believe my time is running out. This video camera is a blessing to me, but it is an old blessing to me. And so anyway, KP the Math G signing off. Make sure that you subscribe if you haven't done so. Do that if you'd like to. If you don't want to, okay. If you want to hit that like button, please do so. See, I'm already smiling when I even talk about it. If you want to make a comment, please make a comment. That'll be all right as well. But at any rate, I just want to help you get better at this. I know we've done several videos on this before, but this is review time. This is getting time for your test. I want to say it's on either the 12th or the 13th of May. So it's just around the corner. And please do your best on this. Okay? KP the Math G signing off. Ladies and gentlemen, have a great